Good afternoon, बच्चों. Am I audible? Visible? Can you tell me whether I am audible or not? Let us start the today's class, and today our focus will be that we will try that we can complete the revision of entire space technology and nanotechnology. This will be our focus. Tomorrow we will do biotechnology, defense technology, ICT. Be our focus. So let us start. There was a little bit delay. Let us start with the space technology without wasting any time. Hope session अच्छी चल रही होगी. Start करें. So in the space technology, we started space technology with the rocket and jet. Then what is rocket? What is the difference between the rocket and jet? So the rockets are non-air breathing. They work on the non-air breathing technology. Why they work on the non-air breathing technology? Because they carry their fuel and oxidizer, both the things in its with it. Because it have to go to the outer space, and in the outer space we don't have any oxygen. And if the fuel have to ignite, and if fuel have to have the combustion, and without oxygen there cannot be any combustion on the fuel. So rocket will carry its own fuel, so that there can be combustion in the outer space. So that is why we will call rocket as the non-air breathing. And rocket system will be used in the ballistic missiles like your Agni 1 to Agni 5, then Sagarika and Shaurya. These all use the rocket system. And launch vehicles like your SLV, ASLV, PSLV, GSLV, these are dependent on the rocket technology. Then what is jets? Jet are air breathing. Jet breathe the air from the atmosphere. Jet takes the oxygen from the atmosphere. Jet will carry its own fuel, but it will not carry the oxidizer. So jet are non-air, jet are air breathing. They will breathe the air from the atmosphere. They will carry the fuel, and the fuel will be ignited using the atmospheric oxygen. And this jet technology will be used into the cruise missiles like your BrahMos missiles, like your Nirbhay missiles, and in the UVs we will use the jet technology. Now we will try to understand about the concept of the rocket launching station. The first rocket launching station that we can see, it was in Thumba. Thumba was in the magnetic equator. Beta, here we are trying to revise the entire space technology today. This is our target. So if you have any question regarding that, then I can answer that. After the class I will give you the suggestion. तब तक आप class ले सकते हैं. So here I am discussing about your rocket launching station. And rocket launching stations, we have 3 rocket launching stations right now. First rocket launching station was established in Thumba. Thumba was in the tip of India. Thumba is in the tip of India. It is in Kerala. So this was our sounding rocket station. From here, from Thumba, we launch our sounding rockets. And the first rocket that we launched, that was our Nike Apache. And why we chose Thumba? Because Thumba has the proximity with the magnetic equator. Thumba is in the magnetic equator, and Thumba is recognized by the UN as the global scientific facility. And from the Thumba we launched the sounding rocket, and this sounding rocket probe into the atmosphere. And even different countries of the world launched their sounding rocket from the Thumba itself. Then this was Thumba. Then again we have Satish Dhawan Space Center, SDSC. Satish Dhawan Space Center is in Sriharikota. Somewhere here, Satish Dhawan Space Center is in Sriharikota, in the eastern coast of the India. And from the Satish Dhawan Space Center we launch PSLV, Polar Satellite Launch Vehicle, GSLV, Geosynchronous Satellite Launch Vehicle. Then the next that is coming is NGLV, and we are making a pad. we are developing a pad to launch the NGLV from the SDSC. It is in the eastern coast. So, because of the eastern coast, what happens? It will reduce the risk to fall the rocket on the populated area, because the earth rotates from west to east. So, if the rocket will fall, it will fall into the Bay of Bengal. Then the third rocket launching station that we are building right now, that is in the Kulsekhapatnam, and it is in the Tuticorin district of the Tamil Nadu. And why we are building this third rocket launching station? Because of its proximity with the equator, and if we will have in Kulsekhapatnam, we will have rocket launching station, then it do not have to maneuver from over the Sri Lanka. So, it will avoid the maneuvering from over the Sri Lanka. So, this will save our fuel cost, and the share of the ISRO in the space economy will increase. This was the reason, and from Tuticorin we will launch SSLV. This is the plan, that from Tuticorin we will launch SSLV, small satellite launch vehicle. Then we have orbits. Then orbits, yes, there are different type of orbits. And why anything orbit around the earth or any other planetary body? In Tamil Nadu, I told you Tuticorin, Kulsekhapatnam. Orbit are the curved path, or orbit are the curved path into the space because of the gravity. Here two forces work in 90-degree angle, in right angle. One is force of the gravity, another is force of the orbital, or force because of the momentum. And these forces are equal, and they are into these two forces will balance each other, and these two forces are in the right angle. That is why anything will orbit around any other stellar body. Then we have different type of orbit. First is your low Earth orbit. Low Earth orbit is from 160 kilometer to 2000 kilometer altitude, and if you are in the low Earth orbit, then what will be better for the low Earth orbit? Yes, from the low Earth orbit, in the low Earth orbit we can have the remote sensing satellite. Remote sensing satellite will capture the picture of the Earth. So, if you are nearby, then there will be the better pictures. And International Space Station, it is also on the low Earth orbit, and the orbit of the International Space Station is somewhat 400 kilometers. This is the orbit of the International Space Station, and International Space Station revolve around the Earth within 90 minutes, and in a complete day International Space Station can revolve around the Earth approximately 16 times. Then we have MEO, Middle Earth orbit. Middle Earth orbit starts from the 2000 kilometer to the 35,786 kilometer, and here we will have the navigation satellite, and one very famous navigation satellite, that is your GPS, is in the Middle Earth orbit, and the altitude of the GPS is 20,200 kilometers. This is the altitude, approximate altitude of GPS. Then after the Middle Earth orbit, we have geostationary Earth orbit. Geostationary Earth orbit, it will be always coplanar with the equator of the Earth. So, and the altitude will be 35,786 kilometer from the Earth. This is the geostationary orbit, and if you are in the geostationary orbit, then you can see one single location of Earth continuously, because in the geostationary orbit, the time that satellite take to orbit around the Earth, it is 23 hours 56 minutes, 56 minutes and 4 seconds. Its revolution speed is equivalent to the orbital speed of the Earth. It means when Earth will complete its one orbit, it will also complete, this satellite will complete one revolution of the Earth. Then GSO, here special theory of relativity will apply. Then GSO, geosynchronous Earth orbit. Geosynchronous Earth orbit, they will not be on the equatorial plane. They will not be the equatorial plane. Here they can be in the different angles, and this geosynchronous satellite, they make figure of 8 on the surface of Earth, and we can have the communication satellite on the geosynchronous orbits. Then by the same, there are some circular orbits. In the circular orbit, we will have the communication satellite. Then we have elliptical orbit. If elliptical orbit are like this, suppose this is Earth and this is one elliptical orbit. In the elliptical orbit, we have perigee and we have apogee. Perigee is the nearest point of the Earth and apogee is the farthest point of the Earth. We use highly elliptical orbit to send the satellite from one orbit to the another orbit. And this sending the satellite from one orbit to the another orbit is done by the low energy transfer. Then by the inclination. If that is inclined, the orbit is inclined towards the equator, then that is called the geostationary orbit. If it is inclined towards the pole, then it will have the global coverage. It will go from pole to pole or make some angle from the pole to pole. Then we have SSO, sun synchronous polar orbit, sun synchronous polar orbit. Here the time, solar time will be fixed, and here it will get the constant lighting of the sun. And if this satellite have visited one place of the Earth at a particular time, then again next time that satellite will visit that place on that same particular point. And here we have Cartosat series. Cartosat satellite are used for the cartography purposes. Then we have Van Allen radiation belt. Then we have Van Allen radiation belt. What is this Van Allen radiation belt? In the Van Allen radiation belt, we have the charged particles. Charged particles. These charged particles are trapped into the magnetic field of the Earth, and we have the two spheres of the Van Allen radiation belt. One is the inner belt. In the inner belt, that is from 1000 to 12,000 kilometer. Here the protons are trapped, and the outer radiation belt, that is 13,500 kilometer to 58,000 kilometers. Here we have the trapped electrons, and these protons and electrons, from where they come? They come from the solar wind. And effect of the Van Allen radiation belt, the effect is that it can disrupt the electronics, it can degrade the solar panel, and it can affect the sensors that are in the satellite. Then how we can mitigate? We can mitigate this impact because of these charged particle by using the orbital shifting, or you can say trajectory planning. Then we have launch vehicles. First launch vehicle that India launched, that was your sounding rocket. Sounding rocket was launched from the Kumba. Then second rocket, that is your SLV-3. SLV-3, it is the first Indian rocket that you can say this SLV-3 had the 4 stages, and all the 4 stages were solid fuel. सब कुछ क्या था इसमें? Solid fuel. And this SLV-3 had the 4 launches. This SLV-3 had the 4 launches, and 2 launches were the completely successful. One was successful and one was semi-successful. Good afternoon, Sivanand. आज आप लेट हो गए. Then ASLV, augmented satellite launch vehicle. In the augmented satellite launch vehicle, we have 5 stages, and all 5 stages are the solid stages. And here the payload capacity will be of 150 kgs. Then we have PSLV. Here we have 4 stages. First stage is solid, then second is liquid, then third is solid, then fourth is liquid. Recently we had the launch of PSLV C61, which was not successful. And with the help of PSLV, we have launched many successful missions like Chandrayaan 1, like Mangalyaan 1, and there is the record of the PSLV that in one go PSLV launched 104 satellite. Then we have another rocket that is called your GSLV. GSLV, it has the 3 stages. First stage is solid, then second stage is liquid, and third stage is cryogenic. And by adding the cryogenic stage, its payload capacity increases, and now the payload it can deliver up to the geosynchronous transfer orbit 4,000 kgs, and in the low Earth orbit it can deliver approximately 10,000 kilogram of the payload. Then we have next rocket, that is your SSLV, small satellite launch vehicle. It will have the 3 stages and all the stages will be solid. It can carry 500 kg up to the 500 kilometer of the orbit. Then PSLV, there are different variant of the PSLV. Core alone, it means there will not be any strap-on motor. Then PSLV general, in the PSLV general we will have 6 strap-on motor. In PSLV XL we will have the 6 strap-on motors with 12 tons of the fuel in each motor. Then we have PSLV DL. In the PSLV DL we will have the 2 strap-on motors. Again QL, the QL we will have the 4 strap-on motors. Then GSLV MK3. First is solid, I have told you. Second is liquid, it will use the liquid Vikas engine, and in the third it will use the cryogenic engine. Now, which propellants will be used in these engines? Solid. If that engine is using solid fuel, the first stage of PSLV, GSLV both is solid. So, which type of fuel will be used? In the solid, we will use the hydroxyl terminated polybutadiene, or you can say STPB, or you can say hydroxyl terminated polybutadiene as the binding agent with the aluminum powder. Then liquid fuel. In the liquid we will have the 3 type of fuel. First is your hypergolic fuel, second is cryogenic fuel, third is your petroleum fuel. In the hypergolic fuel we will use dimethyl, we will use UDMH, that is your unsymmetrical dimethyl hydrazine, or we will use MMH, that is your monomethyl hydrazine. This is your hypergolic fuel, but the problem with the hypergolic fuel is that they are toxic in nature. Because of the hypergolic fuel there can be cases of cancer. It means hypergolic fuel is carcinogenic, and they are also ozone depleting. They also deplete the ozone layer. Then cryogenic fuel. In the cryogenic fuel, this fuel and oxidizer will be in very less temperature. Here we will use hydrogen as the fuel and oxygen as the oxidizer. In the liquid condition, hydrogen will liquefy in -253 degrees Celsius, and oxygen will liquefy at -183 degree Celsius. So, here we will handle the fuel in very less temperature. Then we have the petroleum fuel. Here we will use kerosene as the fuel and liquid oxygen as the oxidizer. So, this is also called the kerolox, or ISRO have named this kerosene as the ISROcene. Then we have green propellant. In the green propellant, what will happen? In the green propellant, they will not, 2 things. First, they will not be carcinogenic, and second, they will not deplete the ozone layer. So, green propellant, in the category of the green propellant, we will have the kerolox, we will have the liquid hydrogen and liquid oxygen, we will have the methalox, CH4, liquid methane plus oxygen. And next is your ion propulsion system. Wherever we require the low thrust, over there we can use the ion propulsion system. Here we will use the ionized xenon gas, and we have used it into the GSAT 20. Then there are key missions and development. PSLV, अभी मैंने आपको बताया कि that with the PSLV we have launched Chandrayaan-1. Then on 2017 104 satellite. Then this Aditya L1 was launched by the PSLV itself, and this was the PSLV C50. And yesterday the day before yesterday there was flight of PSLV C61, that was not successful. Then POEM mission have been performed in the 4th stage of the PSLV. Recently POEM 3 was performed. It was also performed on the PSLV C58. With the PSLV C58 we send the EXPOSAT. EXPOSAT will study the universe in the X-ray. Means it will study the black holes, neutron stars, active galactic nuclei. Then GSLV MK3, it will take heavier payloads to the geosynchronous transfer orbit. The capacity is approximately 4000 kgs. The geosynchronous transfer orbit. Then we have SSLV. SSLV is made for the smaller satellite. It will carry the smaller satellite because its payload capability is 500 kg for the 500 kilometers. Then some private companies entered into the space sector. In India, there is a company that is known as Agnikul Cosmos. Agnikul Cosmos made a 3D rocket engine that is known as Agni-Let, and this Agni-Let 3D rocket engine will be used in a rocket that is called as Agni-Pan. Then there is another company that is called Skyroot. Skyroot is developing 4 rockets. One is Vikram S. S denotes for the sounding rocket. S denotes for the sounding rocket. Then they will develop Vikram 1, Vikram 2, Vikram 3, and on that there will be the engine that will be your Dhawan 1, Dhawan 2 and Dhawan 3. So, Skyroot, in the Dhawan 1 there will be first 3D printed rocket engine, and in the Dhawan 2 there will be the semi cryogenic engine. In the semi cryogenic engine they will use the liquid methane and liquid oxygen. Then we have next launch vehicle, that is your RLV, reusable launch vehicle, that is also known as Puspak. And when the Puspak will be launched, when the Puspak will be successful, अभी तक हमारे पास जो launch vehicle थे, those launch vehicles were the expendable launch vehicles. There was no recovery of any part of the launch vehicle. Each and every part of the launch vehicle was exhausted in the space. And here we have the RLV, that will be the recoverable, and in the RLV we will have the 2 stages. That is why it is also called the 2-stage 2 orbit. Matlab it will place the satellite into the orbit using the 2 stages of the rocket, and here this is recoverable. If we will recover these stages, then the launch cost will be reduced by the 90%. It means the space share of the ISRO in the space economy will automatically increase. To have such reusable launch vehicle, that is also known as Puspak, we have tested certain technology. First is HEX. The HEX, that is the hypersonic speed test experiment. For that we will use the hypersonic engine, and the speed reached more than the 5 to 8 Mach. Then we have specs, that is scramjet engine. We tested the scramjet engine. Then we have LEX, landing experiment. It means the automatic landing. Landing भी तो होनी चाहिए, तभी तो वो recover हो पाएगा. Then REX, reusable test experiment. All the experiments are being performed by the ISRO. Then we have next, that is known as Avatar, hypersonic vehicle program. And here Avatar, to develop the Avatar, ISRO and DRDO are working together, and the Avatar will have only one stage, and it is also called the India's Space Shuttle. Then the next launch vehicle is NGLV, next generation launch vehicle. NGLV is our heavy lift launch vehicle, and its first stage is reusable. For the NGLV, its first stage is reusable, second and third stages are not reusable. By using the NGLV for the first and second stage, we are using the semi cryogenic engine, and for the third stage we will use the cryogenic engine. And here in the NGLV, when we will be using the semi cryogenic engine, our fuel will be the liquid methane, and oxygen will be the oxidizer, and we will call it methalox. First stage will be semi cryogenic, second will be also semi cryogenic, but it will be the vacuum optimized, and third stage will be the cryogenic stage. And by using the semi cryogenic technology, the payload capacity of the rocket will increase, and now the payload capacity increased by, it is the 10% to the geosynchronous transfer orbit. For what was for the it was for the GSLV Mk3, it was only 4 tons and 20 tons to the LEO. And if we want to make it expandable, we can use the strap-on motors. Approximately 6 strap-on motors will be used. Now the payload capacity will be increased. It will be the 30 tons to the LEO and 15 to 16 tons to the GTO. So, in the first stage it will be the reusable, and if it is reusable then it will cut the cost and it will boost the sustainability. Approximately 15 to 20 times our first stage can be used. Here, to launch this NGLV, we are developing one third launching pad into the SDSE. Then we have Gaganyaan and Bharatiya Antariksh Station. Gaganyaan, this is the first India's first human. This will be the India's first human flight, and this will be the stepping stones towards the Bharatiya Antariksh Station. If this will be the Gaganyaan will be the will be a success, then it will become the stepping stone towards the Bharatiya Antariksh Station. And we have planned that on 2035 we will have active Bharatiya Antariksh Station into the low Earth orbit, and this is also our planning that after that we will send man to the moon on 2040. Now, let us study about the Gaganyaan. What is the objective? Here the objective is that we will send three Vyomnauts to the 400 km of the orbit for up to 7 days and with their safe return. आप देखो यहाँ पे क्या है, Vyomnaut. The term is Vyomnaut. For Indians there is Vyomnaut. For Americans it will be astronaut. For Russians it will be cosmonaut. For Chinese it will be taikonaut. And for Indian it will be the Vyomnaut. And it was initially the first flight was scheduled on 2023. Now it will be on 2026. The uncrewed flight will be started by the next year, and when it will be successful, then we will become the fourth nation to send man on the space after Russia, China and USA. We will become the fourth nation to send man on the space. And for the Gaganyaan, now there are certain things needed. How we will send man to the space? For that we will use GSLV Mk3, or the renamed version of the GSLV Mk3 is LVM-3 rocket, that is human rated. On that we will have the crew module and we will have the service module. Crew module will be for the life support for the astronaut and service module for the power and propulsion. And there are four Air Force there are four personalities from the Air Force. Those have been selected to go to the space in the Gaganyaan mission, and these four Air Force personalities will be called the Vyomnauts. First person is Parasnath Balakrishnan Nair, then second is Ajit Krishnan, third is Angad Pratap, and fourth is Subhanshu Shukla. And their training have been completed. The first phase of the training have been completed in Russia, Yuri Gagarin Research Center, and the second phase of the training have been completed into the Indian Air Force Base at Bangalore. And this Mr. Subhanshu Shukla will also travel to the International Space Station before the Gaganyaan mission. It means after the Rakesh Sharma went to the space. Rakesh Sharma was the first Indian person who went to the space at the time when Indira Gandhi was the government, and the mission was from the Russians, USSR sent the first Indian into the space, that was Mr. Rakesh Sharma. After the Mr. Rakesh Sharma, Mr. Subhanshu Shukla will become the second Indian who will visit the space, and before the Gaganyaan mission, Mr. Subhanshu Shukla will visit the space in the Axiom 4 mission. Axiom 4 mission that is planned on this year itself. Then what are the launching date of the Axiom mission? तुम्हारे एग्जाम के बस 4 दिन बाद Axiom mission को launch होना है. It will be launched on the 29th May 2025 via SpaceX Falcon 9 rocket and Crew Dragon spacecraft. And how this Gaganyaan will become successful? For that we need re-entry technology that we have already tested. We need we also have tested crew atmospheric re-entry technology and reusable launch vehicle technology that we have already tested. Then we have the crew escape system, and after that recently we have tested pad abort test. Pad abort test क्या होता है कि before the launch each and everything was okay, and suddenly you have to cancel the launch. That is your pad abort test. Crew escape system, that system when between the mission, the crew have to leave the mission. Suppose this is GSLV is going for the Gaganyaan. Now there is some problem in the GSLV. Suppose the liquid fuel is leaking or the cryogenic fuel is leaking. Now this is throttling like this is throttling like this in the space. Now the mission have to be aborted. Now what will happen? Here the crew module will be ejected from the GSLV, and using the solid motors, crew module will come to the earth, and here the mission will be aborted. This is the crew escape system. And for re-entry, I have already told you. Then environment control life support system, because that inside the crew module 3 person will live, and if 3 person will live inside the crew module, there will be humidity, there will be exchange of the gases like carbon dioxide, oxygen. So the supply of the oxygen should be consistent, there should not be increase in the percentage of the carbon dioxide, and there should be the moderate type of humidity also. And in the space there will be charged particles also, and how the space will behave with the human life. Then only we will make the environmental control life support system, because we have to develop this entire environmental control life support system without the help of any other country. We are developing our own. So for that, to test all of these things, we will send the Vyomnaut in the first and second uncrewed flight, and in the Vyomnaut there will be sensors. Vyomnaut will be laced with the sensors, and Vyomnauts will be laden with the sensor, and this Vyomnaut can simulate the astronaut task, the uncrewed flight. It can speak English and Hindi, it can monitor cabins, it can mimic the movement, it can support psychologically to the astronaut, and it will also have the sensor in its body. When after the first 2 uncrewed flight, when these uncrewed flight will return, then we will study the Vyomnaut, that how the space behaved with him. Then only we will develop our environmental control life support system, so that we can safely, so that our Vyomnauts can safely return to the earth. Then we have Bharatiya Antariksh Station. For the Bharatiya Antariksh Station, we are planning that the mass of the Bharatiya Antariksh Station will be 52 tons, and its altitude will be 400 to 450 kilogram, 400 to 450 kilometers. And what is the altitude of International Space Station? The altitude of International Space Station is the 400 kilometer approximately. And in the Bharatiya Antariksh Station, we will send 3 to 4 astronauts. Maximum it can be 6. And for the building of the Bharatiya Antariksh Station, we will send 5 modules. It means the Bharatiya Antariksh Station will be a modular Antariksh Station like the International Space Station. It is also a modular space station, because in one go we cannot send the entire space station. We have to dock the different components of the space station into the space. So this type of composition is called the modular composition of the space station. And on 2024 the project was approved. Then 2025 the test began. 2028 will be the time when we will send the core of the Bharatiya Antariksh Station into the space. After that, we will send the different units of the Bharatiya Antariksh Station, 4 different units of the Bharatiya Antariksh Station, and they will dock with the 4 module of the Bharatiya Antariksh Station. And this is our plan, that by 2035 the Bharatiya Antariksh Station must be functional. And here the role of the Gaganyaan, the first 2 uncrewed flight, then there will be 2 crewed flight, then docking will start just after the 4, and by 2028, because we are planning that we will send the core of the Bharatiya Antariksh Station on 2028. Then he has a space vision 2047, that phase 1 Gaganyaan, phase 2 Bharatiya Antariksh Station precursor, मतलब core of the भारतीय अंतरिक्ष स्टेशन. Then phase 3 भारतीय अंतरिक्ष स्टेशन ऑपरेशनलाइज होगा 2035 में. Then man landing of the man on the moon. This is ISRO's vision 2047. What will be the impact of Bharatiya Antariksh Station? Yes, we will research on the microgravity experiment, and in the economy there will be enhancement of the jobs, and ISRO will get more and more projects. So this way it can increase your ISRO's global share into the space economy by 2% to the 10%, and this is our projection. Microgravity. Now there is one layer that is known as Karman line. This is the layer above the 100 kilometers of the earth. Karman line is approximately situated 100 kilometer in the 100 kilometer of the altitude, and above the Karman line it is supposed that there is the microgravity, and most of the nations and many of the nations recognize Karman line as the border between the sovereign space and the outer space. And in the Karman line we have above the Karman line we have the microgravity. Microgravity does not denote that that there is zero gravity, because there is nowhere in the universe where we have the zero gravity, as force of the gravity work to the infinite distances. And that is why, because of the gravity, earth is revolving around the sun. Because of the gravity, moon is revolving around the earth. And so why astronaut float in the orbit? Why each and everything float into the orbit? It is not because of the less gravity. It is because that each and everything do the free fall on the space, and the International Space Station we have approximately 90% of the gravity that we have in the earth surface. What is the significance of the microgravity? देखो, in the microgravity we can test the different type of technologies, like microgravity behaves differently with the different things. If you will burn a candle in the earth, it will take the shape. If you burn a candle, then it will take the shape that is like a drop on the earth, or you can say teardrop on the earth. But if you will burn that thing into the space, that thing will become the spherical. Over there the flame will be spherical, and the crystals grow larger and more perfect. This is in the microgravity. So we can do these type of experiments and different other experiments into the microgravity. And now we are the creature who live on the surface of earth. So if we are going to live into the International Space Station or the Bharatiya Antariksh Station, so the space will behave differently with us. We are not habitual of the microgravity. We have to take the training of the microgravity. Lekin still there are many problems that can be caused by the microgravity to the human health. First problem, that is cardiovascular system. Heart does not pump against the gravity, leading to the weakening over time. अब ये एक प्रॉब्लम है. फिर दूसरा, it will increase the risk of the cardiac issues. It will increase the it will decrease the red blood cells, and it will also cause the immunodeficiency. Then musculoskeletal system, there will be weakening of the muscle, there will be weakening of the bone. Then fluid shift. अब अभी क्या होता है कि ऐसे because of the pressure, because of the gravity, the blood rotates from toe to head, or in here क्या हो रहा है, in the microgravity, the fluid that moves to the head, it will cause the facial puffiness and reduce the leg volume. This will be the problem in the microgravity. Then we have sensory motor changes. It will affect the balance and coordination due to the altered gravity cues. Then some other risk of the microgravity. पहले तो मस्कुलर एट्रोफी हो सकती है, फिर बोन डिमिनरलाइजेशन हो सकता है, फिर फ्लूइड रिडिस्ट्रीब्यूशन हो सकता है, देन सेंसरी मोटर डिस्टर्बेंसेस हो सकते हैं. नॉट ओनली दिस, अब हाउ वी कैन काउंटर ऑल ऑफ दीज थिंग्स, वी कैन काउंटर ऑल ऑफ दीज थिंग्स. अब देखो एस्ट्रोनॉट्स भी वहां पे एक्सरसाइज कर रहे हैं, बिकॉज द इंटरनेशनल स्पेस स्टेशन वी हैव मेड अप्रोक्सीमेटली one gym type system. Over there we have treadmills, over there they have the resistance devices, so that the impact of the microgravity should not be that much on the astronauts. They will take the medication and they will also use the pressure devices, so that they can simulate the gravity. Other risk, radiation. Yes, in the space we have more radiation, there are more charged particles in the space. Then isolation. Yes, that is the, over there no one is there, so that is the problem of isolation. Then its distance from the earth is so huge, so that is why there can be ineffective medication, there can be food shortage, there can be no medical care, there can be the equipment failure. अभी तो हुआ ना, सुनीता विलियम्स गई वहां पे और फिर हीलियम लीक हो गई. अब नाउ शी वाज नॉट एबल टू कम बैक. अब नाउ व्हाट हैपेंड आफ्टर 9 months of the mission, she came back to the earth. Then we have another space station, that is space station of China, that is Tiangong. Tiangong, it means the heavenly places in the Chinese, and this Chinese space station it will be in the low earth orbit, and it will have the human presence. And in the Chinese space station we have 3 modules. In ours we had the 5, in the Chinese we have the 3 modules. Kinhe will be the core module of the Chinese space station. And China became the 3rd country to have its own space station after USA, and then Russia, then China, and in 2035 we will become the 4th country to have its own space station. Then थोड़ा सा ये हीलियम वाला पढ़ लेते हैं कि what happened in the helium, and why we use helium into the rocket. देखो helium is a inert gas, and it is the second in the periodic table, so it is also very light element. And so that is why we are using helium into the rockets. Ab why helium is a chemical inert gas, and it does not interact with any other gases, because it is the inert gas, and it is the lightest element after the hydrogen. So ab what happens in the rocket? The rocket, we have fuel, we have oxidizer. Fuel and oxidizer will come into the ignition chamber. अब ये क्या हो रहा है कि ये फ्यूल खाली हो रहा है, अब करना क्या है हमें कि टू मेंटेन द प्रेशर देयर शुड बी वन अनदर गैस दैट शुड बी filled. To maintain the pressure, the helium will be filled, so that there can be proper flow of the oxidizer and the fuel into the ignition chamber. So to maintain the pressure, we will use the helium gas. And one more thing, that the boiling point of the helium is minus 268.9 degrees Celsius. It means at that cryo temperature, helium will become gas, helium will remain gas at even this cryo temperature. So helium gas can be also used for the cooling of the devices into the space. अब यही प्रॉब्लम हुई जिससे सुनीता विलियम्स गई थी उस फ्लाइट से. अब वहां पे प्रॉब्लम क्या हुई? देयर वाज लीकेज ऑफ द helium. When there was leakage of the helium, so it was not safe for the astronauts to come back from the same flight. That is why that flight came back to the earth without the astronauts. That was the Starliner mission. Then we had the SpaceX mission, PSLV C60. The SpaceX mission, what happened? We did the docking of the 2 satellites into the space. यहाँ पे हम SpaceX mission में क्या कर रहे हैं? We are doing the docking of the 2 satellites into the space. अब why we are doing such dockings? Because we have planned Chandrayaan 4. In the Chandrayaan 4, there will be the requirement of the docking and undocking. फिर after that we have planned your Bharatiya Antariksha Station. In the Bharatiya Antariksha Station, we have to do the docking and undocking. There are 5 modules. How they will be connected into the space? Only by the docking system. So, SpaceX space docking experiment, here we use 2 satellites, one is Chaser, another is Chaser, that is SDX-01, then another is Target, that is SDX-02, and they are approximately of 220 kg. And at the altitude of 470 kilometer, when these satellites were rotating around the Earth with the speed of 28,000 kilometer per hour, we perform the rendezvous docking and undocking experiment. Firstly, we perform the docking, then after some time, after some days, we also perform the undocking experiment. This was the primary target. Then we also transfer electric power between the docked spacecraft. Then we demonstrated the composite spacecraft control, and we also conduct the payload operation after the undocking. This was about the SpaceX experiment that was conducted on the January 2025, and this made the ISRO 4th country who performed the docking experiment on the space. The first 3 countries, US, Russia and China. And the significance of this SpaceX experiment was that we have planned sample return mission, that is your Chandrayaan 4, sample return mission, that is your Chandrayaan 4. Without docking and undocking, that Chandrayaan 4 cannot be completed. Then we have planned Bharatiya Antariksha Station. Then we have planned landing on the moon, and landing on the moon on 2040. And now moving towards the Earth observation satellite. Earth observation satellite, they monitor the resources, weather, intelligence and the cartography in the low Earth orbit. And this low Earth orbit, it can be the polar orbit, and in the polar orbit there is a special type of polar orbit, that is your sun synchronous polar orbit. And sun synchronous polar orbit, they cover the entire Earth. If you want to have some spy satellite, then that spy satellite are also launched into the sun synchronous polar orbit, and there we have one series, Indian remote sensing satellite series, that is in the sun synchronous polar orbit. Then we have optical satellite, they are also called the passive satellite. They cannot work in the night time, they can only work into the daytime, because they do not have their source of radiation. They work on the emitted radiation by the Earth. So these are the optical satellite, and these are OceanSat, ResourceSat and CartoSat. Then we have HISIS, hyperspectral imaging satellite for the better contrast. Then we have microwave satellite. Microwave satellite are also called the active satellite. They have their own source of radiation, and because they have their own source of the radiation, they can work 24/7, day and night, in every weather, in every condition they can work, and they can map the resources of the Earth. And the NISAR and the RESET, they are the microwave satellite. And recently 2-3 days back, ISRO also launched one more microwave satellite that was unsuccessful. And with using the microwave satellite, we can do the resource mapping, we can know the agriculture produce, we can know, we can do the coastal planning, we can do the border security. And these microwave satellite are also called the eyes on the sky. Eyes on the sky. With the help of microwave satellite, we can target the, we can know the location where the terrorist camps are there. We can have the picture before and after the attack of the missiles. So these are the microwave satellite. They have a lot of uses. Then we have GISAT. These GISAT are in the geostationary orbit, and there are 3 satellite, Kalpana 1, INSAT 3D and INSAT 3D are, and these 3 satellites are used to make the solar calculator. And this solar calculator was announced by Mr. Narendra Modi on the Glasgow COP26. Then we have the communication satellite. We can have the communication satellite in the low Earth orbit. or in the geostationary Earth orbit. In the low Earth orbit, if we have the communication satellite, then we will be needing the constellation of the satellite, like in the OneWeb. In the OneWeb, that the OneWeb of the Airtel, we have approximately more than 600 satellites. In Starlink, the Elon Musk, they have approximately 10,000 satellites. Then Kuiper, they have many satellites into the low Earth orbit. So if we want continuous communication in the low Earth orbit, so we have to use the constellation of the satellite. बस here क्या होगा, ये पास में होंगे तो connectivity and speed will be faster and latency will be slower, and it will fulfill the lacuna that we have in the field of the 5G, because in India abhi till the date only 30% of the country is connected with the fiber optic cable, and we have launched the 5G services. So if the country is not connected with the fiber optic cable, then it will be difficult to have 5G services, and this lacuna of the internet will be fulfilled by the space internet. That will be, those satellites will be in the low Earth orbit. Then GEO. In the GEO, we have the communication satellite. In the GEO, we have GSAT-9, South Asian Pacific satellite, for the entire SAARC except the Pakistan. Then there are some different military satellite, GSAT-7, that is Rukmani, dedicated to Navy, GSAT-7A dedicated to Indian Air Force, then GSAT-7B, it is under construction, it will be dedicated to the Indian Army. Then satellite based navigation, IRNSS, Indian Regional Navigation Satellite. IRNSS, Indian Regional Navigation Satellite System. So IRNSS, here this satellite based navigation, it work on the model of triangulation. It means we will be needing at least 3 satellites to have the accurate position of the person or a thing, and the application of the navigation satellites are telecom, navigation, search and rescue, meteorology and the missile ट्रैकिंग टेक्नोलॉजी. जैसे अभी हमने ब्रह्मोस फायर किया, उसके लिए हमें क्या चाहिए, IRNSS की जरूरत पड़ेगी. एंड देयर आर डिफरेंट टाइप ऑफ नेविगेशन सिस्टम दैट वी हैव इन द वर्ल्ड. IRNSS ऑफ इंडिया, और यू कैन से NAVIC, navigation with Indian constellation with the 7 satellites, this is ours. Then Quasi-Zenith is of Japan, they have the 4 satellites. Then we have GLONASS of Russia, 21 satellite. Then we have Galileo of Europe of 30 satellites. Then we have GPS of USA that have the 24 satellite. Then we have Compass or Baidu of China that have the 35 satellite. And in the NAVIC, we have 7 satellite, 3 satellite into the geostationary orbit and 4 satellite into the geosynchronous orbit. And in the geostationary orbit, we have satellite from the 32.5 degree east, that is your East Africa, to the South China Sea, that is your 131.5 degree east. It means this cover the entire Indo-Pacific region. With these 7 satellites, we cover the entire Indo-Pacific region. And these NAVIC system, this cover the 1500 kilometer this side of the India and 1500 kilometer of that side of the India. And the accuracy in India, its accuracy is 10 meter, and outside India in the conjoined regions, we have 20 meter of the accuracy. Then in the NAVIC system, this is the only system of the world which is using 2 different type of two frequency of the different bands. It is using L band and S band. In the L band, it is using L5 band, and in the S band, the entire spectrum of S band is being used in the L5 band. Now this L5 band, now in this L band, we are also introducing the frequency of L1 band in the NVS second series system. This will be the second generation satellite of the NAVIC. Recently, on 29th of January, we sent NVS-02, that is the second generation, second satellite of the NAVIC system, and that was supposed to replace the satellite that was into the 111° east in the geostationary orbit. In the geostationary orbit, it was supposed to replace IRNSS-1E, but what happened? It was not able to reach that geostationary orbit, and it is stuck into the highly elliptical orbit between the earth and the geostationary orbit. So there is one more, that is Lingosat of Japan. First time the wooden surface of any satellite have been used for the purpose of the satellite. Lingosat will be the world's first wood panel satellite, launched on 5th of November 2024, and it is developed by the Kyoto University and Sumitomo Forestry, and it is deployed by the SpaceX Dragon rocket to the ISS. So orbit duration, it will orbit for the 6 months, and the name came from the linguum, and linguum is the name in the Latin for the wood, and it will use magnolia wood. And here we have the size is 4" or you can say 10 centimeter per side, and its weight is approximately 900 grams. And देखो यहाँ पे they are also using aluminum. It is not completely made up of the wood. They are also using aluminum framework and some electronics also. So yes, this is the first wooden satellite, but it is not the completely wooden satellite, you can say. Now they are checking how durable the wood will be into the outer space, and how this wood retain the shielding for the semiconductors. This will be the mission, and it will explore as the sustainable alternative wood, as the sustainable alternative to the aluminum. This is the objective, and the significance whether it can replace aluminum or not, because when the aluminum wood will come back to the atmosphere, because of the atmospheric friction, it will burn. But when aluminum comes down to the atmosphere, it produces aluminum oxide, and aluminum oxide harms the ozone layer. Then after the Lingosat, we will move towards the moon. Formation of moon was approximately 4.5 billion years ago, when because of the giant impact hypothesis, there was a Mars-sized planetary body that is called Theia. It collided with the Earth, and because of this collision, the material from the mantle of the Earth ejected, and it coalesced into the space, and after that there was a formation of moon by that material of the mantle. This is the formation of the moon. There is only 1.5° axial tilt of the moon. Because of this only 1.5°, this thing we are going to study. Into the space. Yes, coming towards the moon. This moon have the only 1.5° of the axial tilt, and because of this axial tilt, in the poles of the moons, actually in the south pole we have a mountain system that is approximately average 6 km high, and because of that height, and because of that less axial tilt. In these mountains we have year-long lighting. We have year-long lighting. There is always sunlight on these mountains. That is why these mountains are called the peaks of our eternal lights. And just nearby these mountains, we have the biggest crater of the solar system, that is known as Attican Basin. And it is the permanently shadowed region of the moon. Over there we have the water ice, 600 billion kilogram of the water ice. And in the moon, and what happens in the moon, because of the effect of the tidal locking, the rotation speed of the moon is equivalent to the revolution speed of the moon. It means the moon complete one revolution around the earth in approximately 28 days, and the same time is taken by the moon to rotate around its own axis. So it means there will be tidal locking, and because of the tidal locking, lunar day will be equivalent to the lunar year. And because of this tidal locking, moon is tidally locked with the earth. We can see only one side of the moon, that the side we can see, that is also known as the near side of the moon, and there is another side that is also called the far side of the moon. So the another side we can never see from the earth. If we want to see the another side, we have to go to the space, or we have to go to the moon. Then we will study about the lunar missions. Here lunar missions, we have in India till the date we have announced 5 lunar missions, from Chandrayaan 1 to Chandrayaan 5. Then there will be the landing of the man on the moon. First lunar mission, it was done on 2008 using the PSLV XL. It was approximately near by the South Pole, 69 to 70 degree south. Then Chandrayaan 2, we launched Chandrayaan 2, and we planned that we will have the soft landing on the South Pole of the moon using Chandrayaan 2. Chandrayaan 2 was launched by the GSLV Mk3 on 2019, and this mission had the orbiter, lander, rover, and lander. There was unsuccessful soft landing on the surface of the moon. So the half mission was completed. It means there was orbiter on the orbit of the moon, and lander and rover, they did not complete their mission. Then we had the Chandrayaan 3 on 2023, and there was a successful soft landing on the south pole of the moon, approximately 69 degree of the south pole. And in this Chandrayaan 3, we have the propulsion module, we have the lander, we have the rover. Yes, we have the lander and the rover and the propulsion module. Vikram was the lander and Pragyan was the rover. And in the propulsion module, we have one instrument that is called SHAPE. It was studying the exoplanet signals, or you can say technical signals of the life. Then in the lander, we have a certain instrument. One was ILSA. ILSA was for the checking of the seismic activity. Then we had Ramba. Ramba was to study the plasma density on the moon. Then we had CHASTE. CHASTE was to study the thermal gradient of the moon. Then we have LIPS and APXS for the elemental analysis in the moon. And this LIPS and APXS, they detected sulfur on the atmosphere of the moon, and this LIPS and APXS, they were into the Pragyan rover. Then you need to know about the RTGS technology, radioisotope thermoelectric generator technology, that was used into the Luna 25. Luna 25 was the mission of the Russia, that was unsuccessful. Then we have Chandrayaan 4. The Chandrayaan 4, our target is that we will take back 2 to 3 kg sample from the moon to earth, and we will launch Chandrayaan 4 using the LVM-3, and here there will be the 2 stacks. In one stack, we will have the ascender module and descender module. In another stack, we will have the propulsion module, we will have the transfer module, and we will have the re-entry module. And these 2 stacks will be launched from different LVM-3 rockets, and these two stacks will be launched from different LVM rockets, and these 2 stacks will be docked into the space. After that, after the docking, now these two stacks using the propulsion module will go towards the lunar trajectory, and when they will reach to the orbit of the moon, propulsion module will de-dock, propulsion module will be ejected. Now what will happen? Another, there will be de-docking, ascender module and descender module will be de-docked from the transfer module and re-entry module. Now transfer module and re-entry module will orbit around the moon, and descender module and the ascender module will land on the moon using the descender module. Now there was soft landing. Now what will happen? From the descender module there will be drilling, and there will be sample collection from the surface and subsurface. From the surface and subsurface there will be sample collection, and after collecting the sample, these samples will be put into the two different containers, one container for the surface sample and another container for the subsurface sample. Then what will happen? Now this ascender module, will take off from the surface of the moon. Now this ascender module will come to the orbit of the moon. Here re-entry module and transfer module were waiting, and now this ascender module will dock with the re-entry module and transfer module. Now what transfer module will do? Transfer module will transfer the sample that have taken by the ascender module to the re-entry module. अब re-entry module में sample आ गया. Now ascender module will de-dock. Now there is no work of the ascender module. Now with the help of transfer module, this re-entry module will come towards the orbit of the Earth. Now what will happen in the Earth orbit? When it will be about to re-enter into the Earth atmosphere, the transfer module will be ejected, and only re-entry module will be enter into the Earth atmosphere, because it will be laced with the anti-radiation and anti-heating capability, so that the atmospheric friction should not burn it down. And with the re-entry module, we will collect the sample, approximately 2 kg sample from the, this was your Chandrayaan 4. Then we have Chandrayaan 5. Previously it was also known as LUPEX mission. The LUPEX mission is renamed as Chandrayaan 5. LUPEX mission is with the India and Japan. LUPEX mission will search for the water ice into the south pole of the moon. In the LUPEX mission, what is the speciality? The lander will be made by the ISRO, that will be the Vikram lander. In Chandrayaan 3, the mass of the lander was quite low, and here the mass of the lander will be quite high, and that sorry, in Chandrayaan 3 the mass of the rover was quite low, and here rover's mass is approximately 250 kgs, and the rover will be built by the JAXA, and we will use the JAXA's rocket, that is S3 rocket. This is your Chandrayaan 5. And yes, in the lander ISRO is using 2 engines, one is beam, another is chota beam. Then Japan lunar mission. Japan was the first Asian country to orbit the moon in 1990s, and its mission was the Heat-N mission. Then recently Japan sent the SLIM mission, a smart lander for the investigation of the moon. It was one of the most precise landing under the 55 meters. Then Chinese mission. China have from Chang'e 1 to Chang'e 8 mission. Chang'e 1 and Chang'e 2, they are the orbiter mission. Then Chang'e 3 and Chang'e 4, they send the rover also. In the Chang'e 3 the rover was U2, in the Chang'e 4 the rover was U2-2. Then Chang'e 5 and Chang'e 6, they were the sample return mission. Chang'e 5 sample came from the near side of the moon, Chang'e 6 sample came from the far side of the moon. Then Chang'e 7, they are also sending one mini flyby, and here the Russia and Pakistan joined the China in the Chang'e 7 mission. Then in the Chang'e 8 mission, China is planning to have the International Lunar Research Station on the moon. Then Artemis mission of the NASA, Artemis mission of the NASA. Here in the Artemis we have the 8 mission. First Artemis 1. Artemis 1 will be the unmanned mission for the moon, and it will use the space launch system and the Orion spacecraft. Then Artemis 2 mission, Artemis 2 2025, it will be the manned flyby, and it will be the farthest flyby of the man in the space. Then Artemis 3, here there will be landing of the man on the moon, and before the Artemis 3, they use the capstone mission. Capstone is a microwave oven size satellite that will be placed into some Lagrangian type of point between the earth and moon, where the gravity of both the bodies balances each other, and at the same point they will establish the lunar gateway, that is also known as the lunar space station. And after the Artemis 3, each and every landing from the Artemis 4 will be by using the lunar gateway, that is also known as the lunar space station. And from Artemis 4 to 8, and the plan is that by the Artemis 8, till the time we will send the Artemis 8, at that time we will have the permanent presence of man or the robot on the moon. And Viper was the planned rover that have been cancelled right now. Then after the moon we have Mars. Mars. Let us study about the Mars, or you can say the red planet. देखो, we are not searching life on the moon, we will search life on the Mars. Why we will search life on the Mars? पहले तो मार्स की थोड़ा सा जियोलॉजी के बारे में जानते हैं, एटमॉस्फेयर के बारे में जानने की कोशिश करते हैं. Mars is a red planet because of the iron oxides. Here in the Mars we have a lot of iron oxide into the soil of the Mars, that is why it is also called the red planet. And the Martian atmosphere is made up of the carbon dioxide. Mars have the 2 moons, one is Phobos, another is Deimos. Then Mars mission window. देखो, for the moon we can have the mission whenever we want. We can have such missions, but for the Mars it is not the case. The window for the Martian mission, we have in each 26 months, after 26 months we will have the window to send the Martian missions to the Mars. So we cannot do missions each and every day for the Mars as we can do for the moon. So if right now the window is of 2026, if we cannot launch the mission on 2026, then we have to launch the mission on 2029, then 2031, then 2033. अब देखो, now we will study about the Mars. और भी क्या चीजें, क्या similarity है? It was believed that before 3.5 billion years ago, the Mars had the wet and warm climate, and in the Martian surface we had half a kilometer deep ocean. This is believed by a hypothesis. And if there was a liquid water into the Martian surface, it means that was in the habitable zone of the star, and that habitable zone is also known as the Goldilocks zone. Goldilocks zone क्या मतलब होता है कि if the water is in the liquid form in the surface. So, yes, it was believed that before the 3.5 billion years ago, the Mars had the liquid water into the surface. Yes, if there was liquid water into the surface, then there might be probability of the life, because in the earth life evolved into the ocean itself by the chemosynthesis. So, that is why here we will search for the microbial life, and you know that when microbes digest anything, when microbes do the microbial activity without oxygen, then there will be release of methane, and yes, methane is also known as the precursor of the life. So, what is believed that so methane is the precursor of life, methane can be the precursor of life on in the Mars. अब देखो क्या कंडीशंस है, क्यों हम मार्स को एक्सप्लोर कर रहे हैं. First is this thing that here we have found the methane, and the thing is that ki if there is no life, and if there is no source of the methane, then methane react with the ultraviolet light and it degrades. But the problem is that ki in the Martian atmosphere, the composition of the methane is not declining. It means there is source of methane, be it biological source or be it the natural source of the methane, that we don't know till the date. And there are life supporting conditions in the Mars also, because in the solar system, as in the earth we have climatic zone, same there is climatic zone on the Mars also, and there is probability that there will be subsurface liquid water, if there was liquid water at that time, and earth like features like polar ice cubes, mountains, valleys, craters, rigid poles, warm equators, each and everything we have in the Mars. And there are another thing, as in the earth, in the river valleys you found the rounded stone. So, in the Mars we have also found the rounded stones. So, there might be that at that time there were rivers and Mars was wet and Mars had the water on the surface. Now, different missions for the Mars. ये Mars के बारे में थोड़ा सा जान लिया. First generation mission, it was NASA's Pathfinder. Then second generation, Spirit and Opportunity. Then the third generation, Curiosity rover. Curiosity rover landed on the Hill crater and it found the ancient water flows. And Curiosity lander uses the RTS technology, radioisotope thermoelectric generator. That is why it is still working. Then fourth generation rover, that is your Perseverance rover. Perseverance rover landed on the Zerotto crater, and Perseverance rover with this mission we also had the Ingenuity helicopter. Ingenuity helicopter flew on the Martian atmosphere, and it also had a device that is called MOXIE. MOXIE converted oxygen to the converted carbon dioxide into the oxygen, and this Perseverance rover also have 43 titanium test tube. In this 43 titanium test tube, this Perseverance rover will collect the sample from the Mars, and on 2028 NASA have planned to have a sample return mission from the Mars, and sample will be from these 43 test tubes. From these test tubes the sample will be returned to the Mars. Then there is orbiter for the Mars. It is the orbiter of the NASA, that is pave. Then InSight is the lander of the NASA. InSight will study the Mars quakes. Then there is one mission of the Mars, that is called Hope Al-Amal. Hope Al-Amal is the mission of UAE. Then we have the Tianwen 1 mission. Tianwen, it means the question to the heavens. In the Tianwen 1 mission, they have the Zhurong rover, and they in the Tianwen 1 they send orbiter, lander, rover, all the three things, and this will study soil, water and life science into the Mars. Then we have the ExoMars of Russia and USA, and trace gas orbiter, it will seek the methane. Then Indian Mars mission. In the MOM1, that is Mangalyaan 1, we had only orbiter, and India became the first Asian country to orbit around the Mars. This mission was on 2014, and in this mission we detected methane into the Martian surface. Then recently we have announced Mangalyaan 2. In the Mangalyaan 2, we will have, as in the Pathfinder mission, we had the lander, rover, we have orbiter, lander, rover and helicopter. Here we will also have the lander, rover and mini helicopter in the Mangalyaan 2 mission, and this mission will be launched by the LVM-3 rocket, and it will use for the purpose of the deployment of the rover. There is a technology, that is sky crane technology. This will be used, and scientific instrument, it has PODEX. PODEX will study the dust particle. It has RO, atmospheric density profile, it will study. It has EIS, it will study the solar particle studies. It has the LPEX, it will study the plasma environment research. Then sky crane, it will provide the precise landing over the Mars, and this is how the Mars Mangalyaan 2 will be completed. Then we have Kessler syndrome. What is this Kessler syndrome? Actually, in the space there is accumulation of the many of the satellite, and some satellites are in the junk condition. If those satellites are in the junk condition, they will break down, and if even a single screw, 1 centimeter, a small screw, it collide with the another satellite, it will break the another satellite, then there will be a chain reaction, and this thing is also known as the Kessler syndrome. Then recently India announced the Venus mission, the mission for the Venus, that is your Venus mission, and approximately on 2028 we will send the Venus mission. The Venus mission, our objective is that we will map the surface topography, volcanic activity and tectonic features. We will study the atmosphere, because in the atmosphere of the Venus we have the clouds of the sulfuric acid. We will probe the ionosphere and the subsurface. Then some missions for the Jupiter. JUICE, Jupiter Icy Moons Explorer. In the JUICE mission will study the 3 moons of the Jupiter, 3 icy moons of the Jupiter. One is Ganymede, another is Callisto, third is Europa. These 3 will be studied by the JUICE mission, and JUICE mission was launched by the European Space Agency on 2023, and it will reach to the Jupiter's moon on 2031. Then there was Juno mission of the NASA. Juno mission was sent to the Jupiter to study the Jupiter's atmosphere and the magnetic field along with the gravity, and it discovered the lava lake on Io, and Europa's icy cells were discovered by the Juno mission, and Amtala, the new data on this tiny moon's surface and the orbit was studied by the Juno mission. Then we have Europa Clipper. Europa Clipper is of NASA. This year they have sent Europa Clipper, and Europa Clipper will study the Europa, that is the icy moon of the Jupiter. Here the goal is we have to search if the Europa can support the ocean life. We can study the ice shell thickness and the ocean surface interaction. Then we will analyze the composition of the ocean and the geology. This is the goal, to study the Europa. Then there is one mission, that is Cassini-Hygnus, it was for the Saturn. Then Uranus and Neptune, we have Voyager 1 and Voyager 2. Listen, Voyager 1 and 2, they were launched on 1997 to study the Uranus and Neptune. Voyager 1 went into the interstellar space. It means it crossed the heliopause on 2012. It means it is not into the solar system right now. Voyager 1 and 2, they are using the radioisotope thermoelectric generator, and Voyager 2 crossed the heliopause on November 2018. Right now they are into the interstellar space of the Sun and the Proxima Centauri A. Then the last topic of the day, that is Eddington limit. What is this Eddington limit? So, Eddington limit is that how much matter a black hole can eat in a certain amount of time. This limit specifies that how much matter can be eaten by a black hole in a certain specific time. अब देखो क्या होता है, you know कि that in the black hole we have event horizon. In the black hole we have event horizon. If anything went inside the event horizon, then that thing cannot come back. That thing can never come back. Here we have immense amount of the gravity. Now, if this black hole is eating mass, now this black hole is eating mass, and this mass is accreting around this event horizon. This red is event horizon and this is accretion disk. Now this mass is accreting around the event horizon. Now particles are colliding with each other. Because of the collision of the particle, there will be radiation. And here event horizon is also pulling the force of the gravity. Now because of the radiation, there will be a force that will be outward. It will balance the force of the gravity. So there will be limit that how much mass this black hole can eat, and that limit will be defined by the mass of the black hole, because the more the mass of the black hole, the more will be the gravity in the event horizon, the more bigger will be the event horizon. Now we have discovered some black holes which are eating more mass than this allowed limit, and we don't know why, and they are called extra Eddington black holes. They are called extra Eddington black holes. Some black holes are eating even the 50 times more mass that they should supposed to eat. This is called the Eddington limit. Eddington limit is what? That how much mass a black hole can eat in a certain amount of time, and this is called LID 586 black hole. LID 586 black hole is eating approximately 50 times mass than it should have eaten, and this type of black hole is called the super Eddington black hole. So this is how we have completed the space technology, and this was the last topic of the day. Thank you very much. हो गया.